Hey everyone, today we will be looking at operating with integers. This is a Year 9 tutorial. The materials have been adapted from the Essential Mathematics for the Australian Curriculum 3rd edition, Cambridge University Press. In this video, I'll be focusing on the integers, the lowest common multiple, highest common factors and primes, the negative numbers and rows, squares and cubes, order of operations, and lastly, we will also be looking at the NAPLAN questions, specifically on operating with integers. So when we look at the integers, integers are whole numbers that can be positive, like 1 and above, and negative, -1 and below, and 0. But they do not include fractions or decimals. What a fraction looks like is like half, or decimals look like 2.5, anything 0.5, and like root 2 is not a whole number as well, so it is not an integer. We will be looking at decimals, fractions, and roots and sets in later tutorials, and also in this tutorial about sets. So the lowest common multiple, also known as LCM of two numbers, is the smallest number that is a multiple of both numbers. What that means is, let's have a look at in this example, the LCM of 4 and 6. Well, how do we solve that? Well, first we find the multiples. Multiples of 4. We just have a look. 4, 8, 12, 16, 20, 24. What about the multiples of 6? 6, 18, 24, 30. Now we know the multiples. The list goes on. But what is the smallest number they have in common? 4 and 6. It's not the same. 8 and 12. Well, not the same, but 12. Well, when we look at it, multiples of 4 also has 12, and multiples of 6 also have 12. So therefore, the LCM of 4 and 6 equals 12. Now let's solve another example. We can do the same method. Multiples of 2. You can list 2, 4, 6, 8, 10, 12. The list goes on. We can also look at multiples of 3. 3, 6, 9. List goes on. When we look at it, we can see the smallest common multiple of 2 and 3 is 6. So therefore, the LCM of 2 and 3 equals 6. So this is the first way to solve the LCM problems. There's another way to solve LCM. What if our LCM of what if we have to find the LCM of numbers that are bigger than 2 and 3? Now let's try these two numbers. 16, and 42. If we have to find the LCM of 16 and 42, we can use the little dividing tool. We will write the numbers in, and you can try with, let's say, try dividing with 2. For this one, 8, and 2, 2, 4, 2, 1, 21. Okay, and let's see if we can try dividing with 4 again, 2 again. Sorry, so we get 2, 4. And this number is still not divisible, but it's okay. We're going to copy that. What you can do is finding the LCM. All you have to do is multiplying all numbers together, and then that will give you, let's see, 336. So therefore, the LCM of 16 and 42 equals 336. That is the method 2. This is the method 1. So now we're going to look at the highest common factor, also known as HCF, of two numbers is the largest number that divides evenly into both numbers. It's also called the greatest common divisor, GCD. Let's have a look at an example. The HCF of 12 and 18. One way to solve this is you write factors of 12. We know factors of 12. 1, 2, 3, 4, 6, 12. What about the other factors of 18? We look at this. 1 multiply 18 is equal to 18. So what are two whole numbers that we can multiply to get 18? Well, we can say 2 multiplies 9 equals 18. What about 3? 3 multiplies 6 equals 18. What about 4? Any numbers that we can multiply to get 18? For it will be a fraction now too. Yeah, it will become a fraction. There's no other number. And what about 5? Still be fraction? What about 6? Well, 6 is here. We know 6 multiplies 3 factors. So if the number repeats, that's when we know that we can stop looking for the factors and we can now list them. 1, 2, 3, 6, 9, 18. That's how I do to find the factors of 18. So all you got to do is now back to our question, HCF of what is the HCF of 12 and 18? So the highest common number, highest common factor. You can see 1, 2, 3, 4, it's all the same. And 6 is the highest, the biggest number they both share. So therefore, the CF for 12 and 18 is 6. Now let's do another example. Let's do factors again. Follow the steps. Factors of 16 is, I'm gonna do 1 and 16, of course. 2, 4, 8, and 16. What about another one? Factors of 24 1, 2, 3, 4, 6, 8, 12, 24. So we can see from here the common factors are 1, 2, 4, and 8. So what is the biggest number they both share? An 8. So therefore, HCF of 16 and 24 equals 8. So that's one way to solve HCF of 1624. There's also another way. Method 2. We can use the same way as LCM 16 and 24. Try with 4 because it seems like that number can help us finish this off quickly rather than 2. 4, 4, 16, 24. We can try with 2 again. 2, 2, 4, 2, 3, 6. Now, the number 2 and 3, we cannot divide anymore. So all we have to do is, therefore, HCF of 16 and 24 equals 4 into 2. And we can say 8. There we go. We got the same answer. Let's have a look at primes. So a prime number is a number that has exactly 2 factors, 1 in itself. Well, note, 1 is not a prime number because it only has 1 factor. So we can look at number 2. We can multiply 2 and 1. So 2 is a prime number. Also 3. 1, 3 is also a prime number. 5, 5, and 1 is also a prime number. Is there any other numbers that we can multiply to get 5? Not really. This is why we say it has only exactly 2 factors, 5 and 1. So, same goes with 7, 11, and 13. Now, let's have a look at the composite numbers. It has more than 2 factors. So, number 4 is a composite number because it has factors of, let's say, 1 and 4, then 2 and 2. Yeah, it has the factors of 1, 2, and 4. 6 is also a composite number because it has factors more than 2 factors. And 9 is also a composite number because it has got at least 2 factors. So any number greater than 1, that is not a prime number. So not a prime number. Not 3, 5, 7, 11, 13. List goes on, is a composite number. We're now going to look at the negative number rules. So let's have a look at the first rule. A plus minus B, we will get A minus B. So the simple rule here is when we look at the little plus sign and the minus sign, if we multiply these two, we will get a minus here. So here is an example that we can do. If you get a math problem like 4 plus minus 3, we will look at this one, plus minus, we multiply it, we get 4 minus 3 equals 1. Let's look at another rule. The second rule is that if we have a minus and a minus b in the bracket like this, if we multiply it, we will get a plus sign. So we can solve this example. Let's have a look. A minus and a little minus 3 in the bracket. We multiply it. We will get 6 plus 3 equals 9. Let's look at rule number 3. Well, A multiplies minus B. So now this time it's not plus minus thing anymore. This time is multiply. So our little minus stays the same because there's a plus 1 in front. So if we remember from the first rule, we multiply plus and minus, we get minus, and A and B multiplies AB, like this. So now we can have a look at this example. It's pretty simple actually. You just have to multiply this two number first. 2 multiplies 3 equals 6. And if we look at the invisible plus here and minus, when we multiply that two signs, we get minus 6. So that's our rule number 3. Let's have a look at rule number 4. Minus minus equals plus. It's pretty simple as well. So first you multiply 2, A and B, because of this multiplication sign. And now you also look at minus minus, you have plus BAB. We look at one example. Let's multiply this 3 and 3. We got 9. And one minus minus gives us plus. So we're not going to write that plus here. Rule number 5. It's pretty simple actually. Let's have a look. A divided minus B. Well, when you write normally A divided by B, you can write it in this way, A divided by B. And then, if you remember from the previous rule, whenever we multiply plus, there's an invisible plus, and there's minus here. We multiply the plus and minus, we always get minus. So let's do one example. 6 divided by 3 is 2. And then the invisible plus in front of this number. So when we multiply the plus and minus, we get minus 2. And now, rule number 6. Again, we're using this division rule. A divided by B. we write that first. And then when we look at the sign, minus and minus multiply, we get a plus. There's an invisible plus. So 6 divided by 3, we get, let's do 6 divided by 3 first. We get 2. And then the minus and minus, when we multiply it, we get a plus. But obviously, we're not going to write plus 2. So we get 2. A fun part, again, squares and cubes. I love squares and cubes. We can do rule number 1. A square is always a multiply by a. It's like a double. When we talk about a square, it's a double a. It's not the same as 2a. Okay? 2a is a plus a, which you will be exploring in algebra later on. But in this video, we will talk about just a square is the double a multiply a. And when we look at a square root of the square root of a square is equals, it's a. We will learn more about how this has become a in the later videos, but in this one, I'm just showing you the rule. So, and if a is greater or equal to 0, it must be greater than or equal to 0. So next, in example 1, we're going to look at 7 square. Well, all we got to do is we're going to write 7 square. So what is 7 square? It's the same as 7 times 7. Simple, pretty simple. What about square root of 49? Well, it's pretty simple as well. We are looking at, so something is double in here. So we know that square root of 49 is equal to square root of 7 square inside, and that gives us 7. Now the same rule applies for a cube and the cube root. So a cube is always equals, I'm tripling a's, a. And then, again, it is not the same as 3a's. So, if we look at the cube root of a cube, is equal to a as well. We're going to apply that rules over here. So 3 cube is equal to 3 times 3. And the cube root of 27 is equal to the cube root of 3 cube. That is why Now we're going to explore more about order of operations. So when you think about order of operations, there is one simple rule for that. It's called BODMAS, BODMAS. So B stands for brackets, O stands for order and indices. So it's about which order comes first. Indices is about sets, or whether it's something squared or something cubed. And the division, we know what division is, we know what multiplication is, we know what is addition and the subtraction. We're going to follow this BODMAS order. So in example 1, we will look at this. So again, applying this BODMAS rule, what comes first? Brackets come first. We're going to solve all the things that are in the bracket. So minus 3, minus, we're going to write. We're just simply going to copy it. And we will solve the one in the bracket. 2 multiply 10 gives us 20. And remembering our plus and minus signs from the video, from the earlier examples. We're just going to imagine there is a invisible plus. So it gives us minus 10, minus 20. And then the plus and minus multiply. It gives us minus. So we're going to write minus 13. Then equals. Let's try to do the one in the bracket again, because we're following the brackets order. Minus 3. What's minus and minus give us? Plus 20 and minus 13. So now we can solve this without any brackets. Gives us 17 minus 13, 4. Let's solve another example. Let's have a look at another example. So, and again, we can see the BODMAS. So it's the brackets. We're going to solve the ones in the bracket. So minus 25. As you can see, there are little brackets and there's a big bracket. So what do we do at this point? Well, I would like to try to solve. I'm going to leave the big brackets and then solve the little ones inside. So minus 25 divided by minus 5. I'm just going to copy that because there's no signs to multiply here. And then now, what about plus and minus? That's something that we can do. Plus and minus gives us minus 2. Now, leave the big bracket. And then we just copy multiply 3. Let's just keep going. Now we can solve the things that are in a big bracket. We will follow the division. We're going to follow. So order, and what comes after order, there's a division. I'm just simply following the BODMAS rule. So it gives me, what is 25 divided by 5? It gives me 5. And we need to multiply the minus signs here. It's pretty simple actually. Minus and minus gives me plus. I don't need to write plus there. So I'm just going to copy the rest. So it gives me 3 into 3, 9. Now let's do another example. Okay, so cube root of 27 minus 2 squared plus 1 cube. Again, it's BODMAS. So brackets. Simply copy that numbers that don't have brackets, then solve the bracket one. So when we look at this number alone, it just means minus 2 multiply minus 2. So we multiply 2 is equals 4. And then we look at minus and minus, multiply plus. We're not going to write that. So we don't need this bracket, obviously. Now, done. All we got to do is copy the rest. 1 cube. Let's keep going. So brackets been done. So the order that comes, so the certs and indices. We're going to do cube root of 27 is, we all know that it is 3 cube minus 4 plus 1 cube is just 1, because we know that this little one here, 1 cube, 1 multiplies 1. It gives us 1. Okay, and now keep going. So it's 3. We know that cube root of 27 is equals 3. Now minus 4 plus 1. So minus 1 minus and plus 1. Oh, look at that. Now we got 0. Why? Because we know that 1 minus 1 is equal to 0. We can order it, reorder the plus 1 and minus 1. Now, I want you to have a go at other questions. 1, we've got 1, 2, and 3. All of these materials being adapted from the Essential Mathematics from the Australia Curriculum 3rd edition, Cambridge University Press. If you want to look at more examples, you can refer to that book. Otherwise, you can have a go at these questions I have chosen, and I have modified them. So this is the part which some of you might be waiting for. It's the Year 9 NAPLAN examples and solutions, and it is the calculator part. So all the materials are from NAPLAN 2012, 2016, and 2008 to 2011 test papers from Australian Curriculum Assessment and Reporting Authority CARA website. So the first past paper question, it's in 2016, question 4, page number 2. Is 5 plus minus 17 minus 4. All you gotta do is just pop that in the calculator. So just pop that in the calculator. 5 plus bracket minus 17 bracket minus bracket minus 4 minus equals minus 8. Now the second question, 2014 is this question, 2014 question 23, page 9. What you can do is just pop that in again, 100 minus a fraction, and in the square root, 85 square plus 132 square, then you can move with these little buttons up here and type in 2 equals, it gives us 43. You can use this button to change from fraction to decimals. So 21.5. So here, as you can see, in year 2008, it comes in practice questions for this simple one. How many dolphins are shown on this card? So yeah, just 4, you just shade that in. And like 6 plus 4, it also comes in the practice question on the last page. Or you could just write that answer in. What is the total cost of these 2 stamps? And again, these are all practice questions. In 2010, question 15, page 8, you'll be able to see another question about this one. So Kiri has to find the value of this expression without a calculator. So you see the without. You don't have to use a calculator. Now, which calculation should she do first? Well, you can see the numbers. 20 minus 12 multiplies 9.56.5. So always follow this rule, BODMAS. So is there a bracket? No. Is there order and indices? Well, where are the squares? Where are the certs? Yes, it's certs. So what can you do about it? So that's the second one. So you need to solve the one in the sets. We're just following the BODMAS order. So for 2009 question 31 on page 13, we have write 2009 as a product of its prime factors. What can we do? Let's try small prime numbers first. Okay, is 2009 divisible by 3? Let's do guess and check method. So 2 plus 0 plus 0 plus 9. This is called a guess and check method, and I got 11. Is 11 divisible by 3? No. So we can do a cross. What about, is it divisible by 5? Well, obviously, 2009, 9 doesn't end with 0 nor 5. So it's not divisible by 5. What about, let's try 7. Is it divisible by 7? Well, when we divide it, this is a calculator problem, so you can obviously use a calculator. Divided by 7, it gives us 287. Brilliant. Now we can still divide 287 divided by 7. It gives us 41. So let's check if 41 is a prime number. Well, yeah, if we look at the numbers, the prime numbers rule, 41 has no factors other than 1 and the number 41 itself. So it is a prime number. So obviously, the prime factors of 2009 are 7, 7, and 40. Now we can move on to our non-calculator part. In 2016, question 26, page 9, there was a question about operating with integers. Let's have a look. Jason wants to multiply 35 into 62. Which of these expressions will give Jason the correct answer? So all we are working out is the expressions that will give Jason the correct answer. So we can't obviously use a calculator, so we're going to have to multiply 35 into 62. That gives us 3, 2, 6, 7. 21 plus 0.72170. So it gives us 2170. It gives us 2170. Let's try A. 30 into 60 is equal 1800. And 10. When we plus 1810. Obviously no. What about 30 into 2 is 60. And 60 multiplied 5, it gives us 300. Obviously, when we plus it, it gives us 360. Oh, nope. What about 30 and 62? 5 and 62. Well, for this one, we could do 62 into 30 like this. 1860. I think we might be getting close. 31. We might. Who knows? 7. Ah, there it is. 2170. The answer is C. 2015, we have the question number 2 on page 2. Luca had a $10 voucher to spend on games for his smartphone. He bought 3 games at 1.99 each. Which expression shows how much he has left to spend? So this question, we are not trying to solve the answer. So we're just going to do, so 3 games at 199. So 199 into 3 will be the dollar. And then left is our another clue. So $10 is the total cost minus. So what will be our, it's our B. 2014, question 6 on page 3. There were 22 people at a party. The cost was $24 per person, plus, I'm going to choose blue again, plus $40 extra for the cake. Which of these shows how to calculate the total cost party in dollars? Ooh, now we're going to use that BODMAS again. Ready? 22 people at a party. 22 people. And $24 per person. We can multiply it with the 22 people. And then we're going to have to plus $40. There we go. We got our answer B. In 2013, question 5, we can now solve on page number 3. we have 6 multiply 4 plus 2. What? 4 multiply 5 plus 6. So we need to choose the option. Is it less than? Is it equal? Or is it greater than? To make this number sentence correct. So what we can do is we can solve this on each side. So either this side or this side. This could be the number operation question, and it could also be the algebra question. But for now, let's stick with our order of operation question because we're doing that. I would like to do left-hand side equals 6. Multiplies. Remember our BODMAS, the brackets 1 first. So 4 plus 2 equals 6. So 6 multiplies 6, 36. What about our right-hand side? I'm going to choose a blue. Go back. I'm going to choose blue. The right-hand side equals 4 multiply. There are no brackets, but there is multiplication, and then there's plus. So we're just going to follow that order. 20 plus 6 is equal to 26. Obviously, the left-hand side, the green side, is bigger than the blue side. So we can choose the option C. Now we can check our answers. So operating with integers, part 2011, question 23 on page 9. Sam buys 16 tickets to a concert. The tickets cost 27 each. So $27 into 16. Which of these could Sam use to calculate the total cost? Now, these expressions are telling me we need to find the total cost. Again, the long multiplication. Well, it's pretty simple actually. We're gonna multiply 7, 6, 2, 6, 2, 12, 16. So 7, 1, 7, 2, and 2, 2. And then it gives me, now this is the plus thing, it gives me 432. So 432 is the total that we're looking for. We're going to go at each options. Let's have a look at A. A is 270 plus 6, 276. Because we are solving the BODMAS, remember, the brackets first. And again, B, 270. This time, 270 multiplied by 6. Ooh. Wow. You can do like this. Still is not giving you the answer. So what about C? So I go at C again. 20 and 10 gives you 200 plus 42. It's just 242. So no. What about it must be a last option, otherwise it would be wrong. 270 plus 27 into 6. 42. 162. We can now plus 162. It's 213. Yeah, we got what we wanted. There it is. So a D. Let's have a look at another question. 2010, question 4 on page 3. Tanya recorded temperatures on a mountain over 4 days. Which of the following list shows the temperatures in order from coldest to warmest? So this is your knowledge about rearranging the integers. From the coldest to the warmest. So the coldest always the minus and 0, and then follows 1 and above. Yeah. So what number follow our thinking? Let's go one by one. A 0. After 0, we are expecting not minus. We're expecting 1, 2, 3, 4. So A is out of our list. And B minus 3, well, minus 5. After minus 3, we're kind of expecting minus 2, minus 1. So it's out of our list. And minus the third option, what about that? Minus 5. Well, after minus 5, I'm expecting minus 4, minus 3, minus 2, and minus 1, 0. Still out of our list. What about a D option? Let's have a look at D. Minus 5, minus 3, 0, and 4. Yep, this is the one. Why? Because I'm looking at minus 5. And then after that, I'm looking at, so after minus 4, before minus 5 comes minus 4, minus 3. There it is, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. List goes on. And it is following our thinking. So it's the D. So this will be our last question for NAPLAN 2009, question 11 on page 5. Root 200 is between. So this question is asking you to find what two whole numbers root 200 falls between. That means what two perfect squares is 200 between? So we can, as usual, we can go one by one. So 2 squares, 10 squares equals to 100. 12 square equal to 144. So it's our 200 between 100 and 144. Oh, it's over, way over. So our option is out. We could try our 12 square B. What about 12 square? We know 144. What about our 14 square? Well, it's 196. So Is 200 between it? Nope. Option B is out. What about our third option? Well, third option is 40 square equal to 196. We know that 20 square is equal to 400. So is it between, is our 200 between 196 and 400? Yes, it is. So the answer is it's the option C. So I have popped all the questions that I have solved in this video as a PDF with the solutions and also an empty PDF for you to go over and solve them.